Hello, today we're going to talk about water management. So remember, we only have so much water on Earth, and you can think of it as a water budget. And in this picture here is basically showing the water budget for the US. So what we want to try to do is manage that water so that we can provide a sustainable water supply so that we have enough water for future generations and for all of our needs without damaging the ecosystem itself or severely impacting our hydrologic cycle. So there's basically these different options that we have when we're managing our water. First of all, we can find ways to get more water from our aquifers and rivers or redistribute our water sources to where they're needed. Another option is to desalinate ocean water to turn it into drinking water, or find ways to reuse or repurpose what we're already using. And lastly, and probably most importantly, is we need to just waste less water as it is so that we have more water available. So these are some solutions, and I want you to take a look at these for a second. So they fall into two categories. Either we can prevent the damage from being done in the first place, or we can try to control any of the damage that is done. So there are some different approaches to these things that you should list, and we want to try to always prevent things rather than have to clean up the impacts afterwards. So we're going to talk first about, okay, how can we maybe contain this groundwater in something like a reservoir using a dam to get all of the water that we need in one place. So there are some pros and cons to this. If we use a dam and reservoir system, now we have a year-round supply in areas where you might not have rain all year, but you have these periods of time where you have lots of water coming in, so now you can trap that. It also provides us with hydroelectric power, which is a renewable form of energy. It's something that we definitely want to take advantage of as much as possible. It can help reduce flooding in general because it keeps the water contained in a certain area, and it provides that year-round source that we need for everything else. However, in order to build these things, you usually flood a large area, so that's going to displace people, change the aquatic ecosystems around there, change some land ecosystems into aquatic ecosystems. It's going to interrupt migratory routes for things like salmon. It's going to condense any kinds of solutes, so those could be toxins, those could be salts, and the sediments and all those toxins start to build up behind the dam. It's called sediment deposition, where they're all deposited behind the dam. So you have to find a way to deal with that, a lot of times through dredging or other things. And also the dams and reservoirs are very expensive to construct. I just want to look at the hydroelectric system for a second and kind of see how this works when you have a dam. So you have this reservoir here, and basically down below the surface of the water, you let the water through. The water spins this turbine, which powers this generator that produces the electrical energy, and then that can be taken out by power lines to the surrounding areas wherever it's needed. The water keeps going through, so it shouldn't really affect the quality of the water. You're just using gravity, basically, and the power of that water to create electricity. So the world actually has 45,000 large dams, which are anything higher than about 50 feet high would be considered a large dam. And those capture and store 14% of the world's runoff. And they also provide water for almost half of all the irrigated cropland in the world, and they supply more than half of the electricity to 65 countries. So in the US, we have more than 70,000 dams altogether between our large and small dams, and they're capable of capturing and storing half of our entire river flow in this country. So it's really pretty significant. Again, here are some more pros and cons of a lot of these dams. This is kind of the setup that you would have too. It's always going to be upstream, it'll be more flooded, and then you have the dam and it drops significantly in elevation, and you're able to regulate the water flow down here. Alright, so if we start looking at some of our major areas where we have lots of dams, they tend to be in areas where we have some water shortages as it is. So, for instance, the Colorado River Basin. This drains more than 1/12 of the land in the U.S. As far as the mainland U.S. But because it has so many dams and there are so many places where people are taking water out of it, a lot of times the Colorado River doesn't actually meet the ocean. The other reason why this is such a problem is if you look down here where it drains into the Gulf of California in Mexico. So there's this area of Mexico that's really dependent on this river system also. If we dry it up before it gets to Mexico, now it becomes an international issue. So on the Colorado River, there are 14 major dams and reservoirs. There are canals connecting them. That water in that system is mostly being used in the desert area of the U.S., again, mostly for agriculture, so we can grow crops. It does provide a tremendous amount of electricity, and that electricity provides power for 30 million people, which is a whole tenth of the U.S. population. So any kind of system like this is set up based on gravity. So this is where these headwaters originate, and as they flow downhill, we're trying to capture this in different spots. One of the problems when you set up a system like this is, like we said before, it interrupts migratory patterns. So in particular, the salmon population, it traditionally would travel up this river to spawn. And there's been a dramatic decrease because of these dams, and also because of the sedimentation that comes along with them, and the loss of shade and riparian buffers around the river. So in 1999, the National Marine Fisheries Service extended the protection of the Endangered Species Act to both salmon and steelhead trout in a lot of these western areas, basically everything west from Montana on west, and down to parts of California. And these areas now become off limits if there's still remaining natural habitats to these species. So you can't build a dam there anymore if it's not already there. They also have done things like installing fish ladders, underwater screens and passages to prevent them from reaching the turbine blades, or sometimes they'll turn off the generators to allow them to pass through the system. They also use trucks and barges to actually transport the fish from one part of the river to another. So it's really important to keep things like that in mind, things that happen naturally in the ecosystem when you put in this system of water diversions and containment. So one of the issues that we see in this area here has to do with Lake Powell, and Lake Powell generates a huge amount of energy. It's also a major vacation spot. About 2 million people visit every year and use that lake, which is really a reservoir, basically, as a place to go boating and just kind of a vacation spot. So that lake is the water storage facility for the upper basin states of the Colorado River Compact. So that would include Colorado, Utah, Wyoming, and New Mexico. It's actually located in Utah. And it was built to deal with the spring pulse from when the snow melted up on the mountains and all rushed down at once. It used to cause tremendous flooding during the spring. Well, now it all goes into this lake and it gets stored for later. However, because of climate change, you have much less snow melting off the mountains. We've also had all kinds of drought going on in these western states. So lately it's been getting lower and lower during the summer, and they're not able to release enough water for the downstream areas. And that means that these downstream areas like Lake Mead are also experiencing really low water levels and not having enough water for everyone. Right? So another effect of dams on this Colorado River is they remove the natural sandbars, and those sandbars are really important. So before they built the dam in 1963, the natural spring floods would deposit the sediment in these sandbars, and those became nesting sites for birds. You also had some shallow water along there where the fish could spawn. But after they put in the dams, the sandbars started to disappear and erode away, and the river floor became a deep cut channel. So those deep cut channels are not suitable for wildlife. And basically these people who are practicing water management decided to schedule some regulated floods. And what happened with that is it started to flood those canyon floors, and it helped to restore the sandbars back again. And then that has helped to really mitigate the impacts on this ecosystem as a result. Another case study you should know about is China's Three Gorges Dam, the most massive dam in the world. It's over 2 kilometers long, and the electrical output is about equal to 18 coal-fired power plants. So that's really significant. We want to avoid burning coal as much as possible. It also facilitates ship travel up the river because they have a system of locks where the ships can get through. And some of the issues with this is it actually displaced millions of people who had to leave their homes because basically that area is now flooded, and it's also built over a seismic fault zone, so any earthquakes and things like that have the capability to do damage to it. So it's super huge, and you can see how much it has flooded this area behind the dam. There's a bunch of threatened species that are also living in this area, including the Yangtze's dolphin, the Chinese sturgeon, and another porpoise as well. And these can't migrate anymore up and down here. It's also flooded huge amounts of farmland and places where people were living. So there are a lot of advantages to this dam, but again, a lot of disadvantages. And I'd like you to kind of take note of all of these. All right, so a lot of times, because there are such disadvantages, when a dam isn't really needed anymore, they're being removed. And actually, as of 1998, the U.S. Army Corps of Engineers said it's no longer going to build large dams anymore or take on water diversion projects because of the ecosystem consequences that they have, and also the high cost. So over 500 dams have already been removed. It's a slow process. You have to be very careful so that you don't flood the downstream areas. You also need to be careful because all those sediments and toxins that are built up behind the dam can become an issue for those areas downstream if you're not removing them in some way first. So these are types of water diversion projects, and diversion really means we're transferring the water from one place to another. So that can help because it can make unproductive areas more productive so that you can grow crops in areas you couldn't before. And it also boosts the economy because it creates jobs to complete these diversion projects, but they tend to be very expensive. So for example, in central Arizona, they have a project that pumps water 336 miles from the Colorado River to Phoenix and Tucson. That costs $4 billion. So that's good because it creates jobs, but it's bad because that money has to come from somewhere. Also, the problem with this is it's encouraging unsustainable use of water in areas that they wouldn't normally have enough water. So now people aren't conserving the water as much as they should be. And the original rivers are suffering. You're taking water out of them, so the pollutants that would have been diluted in those rivers start to concentrate, your biodiversity starts to decline, and of course you have less water overall. Another problem with water diversions is usually engineers will use a technique called channelization, where they straighten and deepen the river and they line it with these artificial channels. And by doing that, they take away all of those natural what we call fluvial processes, the way that the river moves on its own when it meanders around, and now it's straightened out. And by doing that, they increase the water temperature. They usually destroy the riparian zone around there, so there's no cover for fish life. The temperature tends to go up and down a lot. You don't have the leaf material, the leaf litter going in to provide nutrients for the stream. You also get rid of these riffle areas, which are these shallow areas where you have really high oxygen because the water's moving around so much, and that's really good for the organisms in some cases. But you also need these pool areas where the water is deep and it's moving slowly so that the organisms can kind of cling to the stream bed. When you channelize it, you tend to get some more riffle a lot of times because the water's moving even faster, but none of those pools, and you really need both in a good stream habitat. So one of these water diversion projects that's really controversial is what's happening in California. There's not a lot of water in Southern California, but there is a lot in Northern California. So they're diverting that water down to the southern area. And one of the things they use to do that is an aqueduct. So an aqueduct is an artificial channel that's constructed to convey water from one location to another. It could be canals, pipelines, inverted siphons, reservoirs, and tunnels. And you've probably seen the Roman aqueduct. So this is something that's been used for thousands of years by people, but our modern aqueducts are a little bit different and are usually underground, although sometimes they're above ground and boats and things can go through them as well. But basically, you're just transferring this water using gravity to power the aqueduct. Now, this can cause some major problems when you're diverting this water. So one example of that is the RLC. This used to be the world's fourth largest freshwater lake. But diverting the water from it has created a huge ecological, economic, and health disaster. About 85% of the wetlands around the lake have been eliminated, and roughly 50% of the local bird and mammal species have disappeared as a result. So since 1961, the sea's salinity has also tripled because it's being concentrated, and the water levels have dropped by 22 meters. So think about meters, almost a yard. That's really significant. You can see the change in the shape. And that's probably what's causing 20 out of the 24 native fish species to go extinct as well, as those salinity and depth changes. So you really have to be careful when you move too much water. Alright, then one other option for getting enough water is called cloud seeding. And basically, cloud seeding relies on how clouds form in the first place. So clouds naturally form when you have this updraft of air that has some humidity in it, but then it also needs these small particles called nuclei that basically those water droplets can cling to and form a cloud and condense. If it doesn't have the little particles, they won't form a cloud. So the idea of seeding clouds is they put particles up into the air that this water can stick to and form bigger and bigger droplets until it falls. So that's basically the idea, is the water goes up, it sticks to these nuclei, it builds a bigger droplet, and eventually it's going to be heavy enough that it's going to fall down as rain. And a lot of times they will do this in the winter, and in that case they would be using something like a generator to put silver iodide particles out into the air. That's the actual seeding, or sometimes they'll do this from a plane instead. And then that seeding of the cloud allows more water to crystallize or to form droplets around those nuclei, and then they fall as snow, and that spring snowmelt helps to feed the rivers and the lakes. This is really expensive, it's very experimental, it's not something that we really can rely on yet as far as producing more water, and it's not going to produce more fresh water worldwide. It would just move the water around to places that we might need it. Alright, another option is desalinating seawater. Because most of our water on Earth is saline, 97%, that is a big source that we could take advantage of. The problem is this is very expensive because it requires a really large energy input, and that's a whole nother issue because then you have to have renewable energy to power it. It also produces large amounts of salty wastewater and solutes that you need to dispose of. And if you dispose of them in a local ecosystem, if you're dumping salt into an ocean where you already have a productive ecosystem, you change the salinity, that's going to harm the organisms. The cost of this can be up to $3.50 a cubic meter, and normal tap water is 10 to 15 cents a cubic meter, so this is really significant. So there's two main ways you can desalinate seawater: distillation or reverse osmosis. Distillation heats up the salt water until it evaporates and it leaves behind the salt, and then you collect that evaporated water and condense it. Reverse osmosis uses a high pressure to force salt water through a membrane filter. So salinization is really important in areas that really don't have other options, and you can see Saudi Arabia is one of the largest users of this process. And if you look by region, the Middle East definitely does this more than anybody else, followed by North America and Europe. It's actually becoming more and more popular in Australia as well, though. So this distillation process, again, basically you boil the salt water so that only salt is left behind. It produces the steam, you condense off the steam, and at that point that should be pure water that you're collecting. So solar stills, if you're ever in a survival situation, or if you've used this camping, that's a form of distillation. Reverse osmosis, you're putting extreme pressure on that salt water to try to force it through this membrane, and the membrane is impermeable to salt, but it is permeable to water, so the water can pass through. The salt and the other things like microorganisms stay on that side. And it does remove 97% of salt and other contaminants. So there are actually over 7,500 desalinization plants worldwide that use this reverse osmosis process. But it's very expensive because you have to put a lot of energy in to make this amount of pressure force the water across the membrane, because it's not going to happen on its own. So they're looking at ways to reduce the cost of these technologies, and there's a bunch of things that they might be able to use to do this. But you can see the biggest cost is that energy cost, that or the actual filters themselves cost quite a bit of money, and the capital cost to keep the building going. But the energy is the biggest problem here. All right, so if we don't want to do all of these expensive things with our water, then one of the things we can do is just waste less water in the first place. So we waste about 2/3 of the water that we use, which is really significant. It would be much better if we could cut that down to 15% of what we use, which actually would not be that difficult if everybody is being mindful. So a lot of that water is lost through evaporation, leaks, or other kind of silly losses. And water is also really underpriced, and that allows people to kind of take advantage and waste it when they really should be conserving it. So if we start looking at creating government subsidies or tax breaks for improving your efficiency of your water use, that could help reduce water waste. Also, raising the price of water reduces water waste very significantly. When Boulder, Colorado introduced water meters, the water use per person dropped by 40% in the city. A 10% increase in water prices tends to cut domestic water use by 3 to 7%. So people do things like take shorter showers, use less water in the bathtub, use less water to wash dishes, etc. When we are looking at this, we also want to look at industry and agriculture. So a lot of industrial processes can be redesigned so that they don't use as much water in the first place, or they're recycling the water that they use. We want to try to make sure we're wasting less in agriculture, because remember, that's 70% of our worldwide water use. And 60% of that is currently being wasted. But we could cut that to 5 to 20% using new irrigation systems. So things like center pivot low pressure sprinklers that spray water directly onto the crop allow more than 80% of the water to get to those crop plants. And that has really helped with the Ogallala aquifer out in Texas. Using things like drip irrigation are even more efficient. So anytime you can increase your efficiency, get away from this what we call flood irrigation system, where you just put as much water as you can on the plants and let it drain away, and getting the water directly to where it's needed can really help. So this drip or trickle irrigation, super important. We call this micro irrigation because you're putting water right where it's needed, so you don't have to use as much of it, and it can reduce the amount of water you need by 40 to 60%. So that's a good thing for farmers as well, because they don't have to worry about obtaining that much water in the first place. There's a lot more to go around. Of course, these systems can be fairly expensive to put in, but once they're there, they can work really well for quite a long time. So these are all more ways that we can reduce irrigation water waste. And I'd like you to pause here and write down some of these. Just to explain some of this, polyculture, that would be versus a monoculture. You're not just growing one type of plant, you're growing different kinds. And then they have different root systems. They might pick up water from different areas. Also just making sure your crops really fit your environment, and that you're not growing something that needs a lot more water than what you're going to get naturally. Importing those water intensive crops instead of trying to grow them yourself can really help. So this is kind of our agriculture of the past compared to agriculture of the future. We imagine a system where the water is getting much more directly to the plants, so they're not being wasted. Also incorporating things like aquaponics, where you are using a system that water is going to be reused to create a couple different things. So you're raising fish at the same time. Those fish produce waste. You have some microbes to break down the waste that becomes fertilizer for the plants, and then that plant water that was used to water these plants and grow these plants winds up back in the fish tank again. That's a really sustainable system. Another really important thing to do is to maintain healthy riparian zones around rivers. Usually for agriculture, a lot of these riparian zones will be destroyed, but this actually hurts the water quality really significantly, and that can in turn hurt the agricultural system again. So restricting the access of the animals to that river, building back up that riparian zone can really help improve your water quality so that you can use more of it in your fields. Um, and in general, both on farms and at home, one of the things we need to focus on for water conservation is how we deal with waste. So if we're using wastewater, try to use those nutrients for something else. Once you have those nutrients in the wastewater, they can become soil fertilizers. You can use things like waterless composting toilets that will convert the waste into soil instead, basically into compost. And that way you're not using water. You can also design those aquaponics systems where that waste is becoming nutrients for other organisms. So we need to get creative with things like that. We also need to start to conserve water in as many ways as we can personally. So doing things like installing low flow appliances or high efficiency appliances when it comes to washing machines and things like that. Making sure that we fix leaks, using gray water, we'll talk about that in a second, trying to find ways that we can recycle, reduce, or reuse our water. And a couple particular things I want to talk about here that have to do with this are Xeriscaping, which is basically a gardening form where you use these drought-tolerant plants and grasses, or at least native plants and grasses, for landscaping, and then they don't need as much water, so you don't need to have sprinkler systems or anything like that. Of course, this does require that you adjust a little bit to not having lawns in front of your house, to having other sorts of plants and things instead. Also, really important one is using gray water. So we're going to talk about gray water a little bit more next time, but basically this is water that has some things in it because you've done things like take a bath in it or you've washed your clothes in it, but it's not really contaminated to the point that it's harmful for you, so you wouldn't want to drink it, but you could still use it for other things. So the idea is you collect this water from your bathtubs, from your sinks, from your washing machines or dishwashers, and then it gets filtered out to get some of the major contaminants out, and then you could use that water in your toilet. Since your toilet water doesn't need to be super clean anyway, you also might be able to use that water to water your garden, since those extra nutrients would be good for it. Right, so all of these ways are ways that we can conserve water and manage our water resources better. So we really want to focus on this water management as we go further. All right, I will see you tomorrow. Have a good night.